Hey yo Islanders, welcome back to my channel. As always, I'm Will, and today what we're going to be talking about is merge sort. Why is merge sort so important? Well, it is a really awesome algorithm that allows you to sort through unsorted arrays. And it's honestly a great thing to have in your toolbox. So without any further ado, sit back, relax with your favorite snack, and let's get started, shall we? Also, before we continue on, I just want to shout out to all of my subscribers. Thank you so much for hitting that subscription button as well as that bell icon. And if you're not yet subscribed, what are you waiting for? Go ahead, pause this video or get out of full screen, go hit that red button, make sure it turns gray, and then hit the bell icon right next to it. So without any further ado, why don't we actually start talking about what today's video is all about. Alright everyone, so I got my good notes up on the screen. Just like last video, I'm going to be showing all of you another sorting algorithm that's honestly really awesome. The last video I showed you how to do it both recursively as well as non-recursively. Merge sort, the only way you're going to do it is to do it recursively. That's why it's O log n, but that's why the runtime is O log n. However, the merging is going to cause it to be O of n, and I'll explain all those time complexities in just a couple of seconds. But honestly, merge sort, if you're looking for something a lot faster than insertion sort, merge sort is the way to go. So, if you don't know what recursion is, I actually have a video a couple weeks back about recursion. Go check that video out if you want to know more in depth about what recursion is, as well as if you don't know what insertion sort, I really do suggest going to check out insertion sort as well. So, we have this array 6, 10, 1, 5, 9, and 2. And as all you can see, it is unsorted. So what merge sort does is we're going to take this array and we're going to split it right down the middle. And we're going to say this is left and this is right. So just like here, split it right down the middle. 6, 10, and 1 are considered the left array. And then 5, 9, and 2 are also considered the right array. So it's very important that you split this array down the middle or you're going to get a whole boatload. If you don't split it right down the middle, it's kind of not merge sort anymore. So as soon as we split this up, we're going to then split it up again. We're going to split these two arrays up again as well. So 6, 10, and 1 is going to get split up to 6 and 10, and then 1's on its own. 5, 9, and 2 is going to get split up to 5, 9, and 2 is going to be on its own. So 2 and 1 are considered the right arrays in accordance with what they're sorted. Well, let me re-explain it. 5, 9, and 2 is considered the right array. 5 and 9 in that array is considered the left array. Then if we go over to the original left array, 6 and 10 are the left array, and 1 is the right array. Now so that is how it's O log of n. We're splitting this thing in half. So the time complexity is always going to get smaller and smaller and smaller, hence why the time complexity for splitting apart is O log of n. The best way to think about time complexity is the best way to think about if it's O log of n is if you're splitting in half. Computer science, you're always splitting everything in half, so it's always going to be O log of 2. O log of n base 2. When it starts getting tricky is when we start sorting through this array. Alright, that's when your time complexity becomes essentially it becomes O of n. And the reason being is just like this. So we're going to take 6, 10, we're going to first sort 6, 10, and 1. We're going to look at, we're going to first look at 6 and 10. 6 and 10 are, 10's less than 6. 10 is greater than 6, so 6 and 10 are sorted already. Now 1, we're going to look at 10 and we're going to see that 10 is greater than 1, so it can't go there. We're going to go again. 6 is greater than 1, so it goes after this as well, but there's nothing over here. So therefore, 1's going to go before 6. So the left array becomes 1, 6, and 10. All right, and again with the original right array, we have 5 and 9. 9 is greater than 2, so it can't go in that place. 5 is also greater than 2, so it can't go in that place, and there's nothing behind 5. So therefore, we're going to essentially we're going to move this array. We're going to move essentially, we're going to take that 2 which was at the end and put it at the very beginning of the right array. Now, this is when we start merging the two lefts and the rights together. And the best way really to think about it is that you're going to go cell by cell. So the first cell of the right array, we're putting back into the left array, is to essentially start, the first cell of the right array is 2. So therefore, we're going to compare 10 and 2. 10 is greater than 2, so it can't go there. 6 Then we're going to go down and we're going to see 6 and 2. 6 is greater than 2. So therefore it can't go there. Now we see 1. 1 is less than 2. So therefore we're going to essentially split it down the middle, and we're going to add 2 in between 1 and 6. Alright? Now we have 5 and 9. 5, again, we're going to take 5, we're going to look at it against 10. 10 is greater than 5, so it can't go there. So now we go down and we're going to start looking at 6. 6 again is greater than 5, so it can't go there. So therefore we're going to look at 2 next. 2 is less than 5, so therefore 5 is going to go in between 2 and 6. Now the last one is going to be from 9. It's going to be 9. So, like the other ones, 10 is greater than 9, so it can't go there. So now we look at 6. 6 is less than 9, so therefore 9 is going to go in between 6 and 10, and you have your unsorted array. Your unsorted array turns into a sorted array right here, where it goes 1, 2, 5, 6, 9, and 10. Now comes the fun part where I show all of you the code. So we're going to go into a really cool time lapse right about now, and I'll see all of you in a couple of seconds. Bye. Alright everyone, so I'm back, and why don't I just, real quick, let's go up to the top on line 1. So line 1 is just a function definition for merge. Now what this function is it's going to take the two arrays and it's going to combine it into one sorted array. So that's what's going on inside this first function. So let's go line by line to figure out exactly what each variable is doing. Now, first up is on line 4 and 5 are the two upper bounds of both the left and the right. Line 4 is the upper bounds for the left array. Line 5 is the upper bounds for the right array. Now you're going to notice the math. It's kind of a little funky. It's mid minus low plus 1. Now we don't want mid exactly. We don't want the exact number at the middle. So that's why we add that plus 1. Just in case, so essentially, which will allow us to be able to then go into the right upper and say high minus middle. Alright? Because again, that middle is supposed to be the middle number of the array. After that, we're creating the two lists that we're going to be splitting the original list into. Do not make an empty list right here on line 7 and 8. If you do, you're going to cause some errors where you're going to go out of bounds. So what I recommend doing is using a formula like I did. Left equals the 0 index times the left upper bound. So what we're essentially doing is 0 isn't 0, so the 0 index isn't 0, it's 1. So we're saying 1 times whatever that is. Alright, so if the left upper is 2, we're going to have 2 spots inside of the left. We're going to have 2 available spots within the left list. Alright, same thing with on line 8, same idea. It's the 0 index times the right. It's 0 index times the right upper. Remember, 0 is not 0, it is more like 1. We're just using the index, essentially. And then we're going and we're actually populating both the left and the right on lines 10 and lines 13. Alright? So we're just saying left at index I equals list at low plus I. So low is going, since our for loop is not going to be essentially going in the same correspondings as the list, it's going to go more corresponding with the left list. So that's why we add a index of low plus I. Now, right underneath, we're going to be populating the right array. Now, you're going to notice here it's got a little bit more of a funky one. So mid plus j plus 1. So essentially what we're saying is we want to start at the middle, and we want to, but we don't want to start exactly at the middle because the left index is also going to go to that value of mid. So we want to add that +1, including to the j and the middle. So let me rephrase that. So since left is going to go to exactly the index of mid, we're going to also say we're going to add that +1 for when we're populating the right array. So the index we're actually calling is the middle middle plus j plus 1. All right. After that, we're going to be we're going to be creating 3 integers. I and j are going to equal 0. I and j are going to be corresponding with left and right. The reason why I picked I for this one is because we're going to be using I for the rest of this program with association to the left array. Alright? And then also j, same thing as the left, but it's going to be for the right array. Now k is going to be in correspondence with the original list. Alright? So that's why we're setting it equal to the low value. And this is where we start reorganizing the original list. Starting right at line 18, we're going to be saying while I is less than lower upper and j is less than right upper, we're going to be doing all of this stuff. Where if left of I is greater than the right of I, we're going to make list of k equal to left of I, and then we're going to add +1 to I. So it's going to say list at k equals left of I plus equals 1. So essentially we're saying I plus itself, I is going to equal itself +1. Alright, so if it's 0, if I originally was 0, it's going to now become 1. Else we're going to say, so if this if statement becomes false, then we're going to go to this else statement where we're saying list at index k equals right at index j. Then after that on line 24 we're going to say j plus equals 1. Same idea as what's going on with I plus equals 1. Then once we get out of this if statement, we're going to say k plus equals 1. Alright? We don't want it inside any of these. We don't want it inside this if statement, and we don't want it inside of this else statement, because if we do that, our original list is not going to get reorganized. Then after this, so once one of these becomes false, it's going to go therefore onto this next part, where it's going to say while I is less than left of upper and while j is less than right upper. These two, so line 26 to line 33 are doing the same exact thing, except we're taking, if there's anything left over inside of the left array or the right array, we're going to then still populate it into the original, we're going to populate it into the prospective origin of the original list. So let me just go over the code. So while this is true and this while statement is false, if for some reason right upper, j is greater than right upper, we're going to say, we're going to go to this first while loop where while I is less than left upper, we're just going to say list at index k equals left at index I, as well as I plus 1 on line 28, and then k plus equals 1. Then underneath that on line 30, if for some reason I is greater than left upper, and it comes out of this while loop, and this while loop is false, we're going to go, this j loop is going to become true. Now there is a possibility that there is a possibility where this while loop, as soon as this while loop becomes false, the other two are going to become false. It really just depends on the size of your list. But just real quick, what's going on in line 30 is the same thing as what's going on in this while loop on line 26. So the same thing, it's just making sure that everything gets into its prospective spot that it needs to get to. So after that, this is where we actually start, this is our recursive function. This is where we actually start the recursion, where we're going to be passing in a list. We're going to have a low value and a high value. So our base case for this recursive call is if low is less than high, this whole recursive call gets called out. It gets stopped. While this if statement is true, mid is going to equal low plus high minus 1 divided by 2. Now the reason why it's not like that and it's like that with the double slashes is because if you go like this, it's going to be a float. double slash divided by 2, well, double slash then the 2, or double slash and whatever number is going to be, essentially you're calling the floor method, where whatever that value of low plus high minus 1 divided by 2, if it's not a whole number, it's going to bring it to the low. It's going to use the floor method to figure out what is the lowest, what is that value actually without a float. Then after that, we're going to call merge sort, all right? So merge sort is essentially, we're calling this recursively, but this is the left this is us splitting this thing into the left array, all right? And so we're gonna have list, low, and then mid. All right. So going to this merge sort, the first one's going to be splitting our array into its left and right upper bounds, and we're going to be more focused on the left bounds in this recursive call, where we're saying list. We're going to be passing in the list as well as the value of low and the value of mid. All right. So that's really what's going on, and mid's going to be, when this recursive call gets brought back up to here, mid's going to become the new value for the high. So that's why we're splitting. That's why I say we're splitting this array into its left and right bounds, but we're fixating on the left portion of the array. Then after that, we just have a print statement, and the print statement is really just so all of you can see this list get put into order, which I'll go over as soon as we're done explaining the code. So you don't have to have this to have it correct. So if I'm just going to delete this right now, and then later I'll add it back. After that, this is where we start focusing down on the original right side of the list or array. And we're just going to say, we're going to pass in the list, and then our new low value is going to become mid plus 1. So since we're passing in the original value of mid, we can't pass in the original value of mid when we're fixating on the right side, so we have to add plus 1 so that we can actually organize this list into what we want. And then high is going to stay the same. And the last part that we're going to call in the recursive call is we're essentially going from here all the way up to merge, all right? And this mid is the same mid as that, all right? And now comes the array that we're going to be organizing. The array we're going to be organizing is this array right here on line 41, where it's 6, 3, 8, 3, 9, 1. And then n is just going to be length of the array minus 1. Don't just have length of array. It's not going to work. So you have to do minus 1, and it will work. Then we're going to be passing in the array to merge sort, and we're going to say the lower bounds is 0, that's why that's a 0 there, and then n is this n. And so if we print this out, if I can, let me run you, 1, 3, 3, 6, 8, 9. So the original array was 6, 3, 8, 3, 9, 1. Now the thing you got to think about merge sort, which is actually pretty cool, is that it is considered a stable. I may have this wrong, and if I am wrong, please leave it down in the comment sections. But since this 3 in the original array came before the other 3. So therefore, it's considered stable because the 3 right here this 3 is still the original 3 right here. Like, they didn't switch swap. But anyways, as all you can see is that the list did get sorted. Now, you don't have to worry about putting in double values like we have here, 3 and 3. It doesn't matter. You can change this out with a 4, and it's going to be the same thing. 1, 3, 4, 6, 8, 9, 9. So as all you can see is that it doesn't matter if you have if you have multiple numbers. It's still going to be the same value, where we have 1, 3, 4, 6, 8, 9. For those of you that made it this far in today's video, thank you so much for watching. If you're not yet subscribed and you did make it to this point, please consider hitting that subscription button as well as that bell icon so you can get notified when I post my next video, because on this channel I teach all of you robotics through machine learning and artificial intelligence. Alright? If you enjoyed this video, please consider hitting that like button. It really does help support this channel. Since you made it this far to today's video, why don't you consider watching one of the videos that's coming up on the screen right about now. Thank you so much, and I'll see all of you in next video.